So in my last lecture, I have already discussed what is exception and what is exception handling. This part is already discussed, and I already discussed the type of exception also. Some are the checked exception, some are unchecked exception, and some are the errors. And if we are facing some errors from the programmer end, we don't have to do anything because we don't have any way to solve it, because it is regarding the hardware problem in most of the cases. Just like out of memory error, it's a virtual machine error, it's a stack overflow error. So this type of errors are classified as the errors. It is not exception, it is not syntactical error, it is type of errors which belongs to the throwable class. In the last class, we have already discussed that this object class is basically coming from java.lang. From java.lang it is coming, and under this java.lang we have object class. Under object class we have a throwable class, and under this throwable class we have these exceptions. This exception is the actually parent class, mother class of all type of exceptions. Some of those are the checked exception, some are the unchecked exception. Under checked exception we have IO exception, SQL exception, class not found exception. We are talking about IO exception in last class, and today I will show you some examples regarding this. And we have discussed about unchecked exception that we already handled in the last class, and we discussed we have to handle it by using try and catch block. The code that can generate an exception, we have to write that part of code inside try block, and that try block will basically throws an exception object like arithmetic exception, it's a null pointer exception, index out of bound and exception. Under index out of bound exception, there are two types of, it is array index out of bounds exception and string index out of bounds exception. So this type of exception are classified as unchecked exception, and unchecked exception will not give any error at the time of compilation of a program, that I already discussed in the last class. But in the checked exception, in case of checked exception, if you not handle it, or rather if you not declare it, you will get an error at the time of compilation. Today I will show you different examples on checked exception. So this much we have discussed in my last lecture. Today we are moving to some examples regarding this exception classes, or rather different type of exceptions, and some rules and regulations for the exceptions that we will show through different type of examples. Let me move to the programming example. Is this screen visible to you?
No, sir.
No, sir.
Coming to the next program, that is 23. What it says all catch blocks must be ordered from most specific to most general. Today also I have shown you the hierarchy of the exception classes, just I shown you. And what we shown the exception is the parent class. Under exception we have arithmetic exception, like array index out of bound exception. Not only array index, it is index out of bound exception. Under index out of bound exception, it is array index out of bound exception and string index out of bound exception. So which one is the most general? Definitely the exception class is the most general one, because it is the parent class. And under this exception class we have this arithmetic exception, and under this exception class we have this array index out of bound exception. So we have to write the exception, rather catch blocks, in this order. Why in this order? Most specific to most general. So is this form this most specific to most general? No. Most specific is arithmetic exception, array index out of bound exception, and most general is the exception class. Is it clear? Is it clear? Which one is the most general here? Which one is the most general here? Definitely the exception class, because this is the parent one. And this arithmetic exception and array index out of bound exception, they are the child of this exception class. That means they are the most specific, because this is the child. So if you try to compile this file, look, you are getting errors. Why you are getting errors? Because in the last class I mentioned that one try block can have more than one catch block. In this example, this is reflected that one try block has more than one catch block. What is the parameter of catch block? That is a reference of different exception classes that I already discussed. Now, my question is, if we have more than one catch block, which catch block needs to be write first? The answer is from most specific to most general. Which one is specific and which one is general? Definitely the parent class is general and the child class is specific. So here I am talking about arithmetic exception, array index out of bounds exception. So these are the child class of the exception class. So as because I have written this order, exception, then arithmetic exception, then array index out of bound exception, I am getting some error when I am compiling this file because I haven't followed this order, most specific to most general. I have done it in reverse manner, most general to most specific. That's why I am getting error. Is it clear to you? Do you have any doubt?
Yes, sir, clear.
Clear. So points to be noted that catch block, for a single try block there can have more than one catch block, but the order you must have to follow to write the catch block is this, from most specific to most general. Moving to the next example. What is finally block? Do you know what is finally block? I haven't discussed finally block. In the last lecture I discussed about try and catch only. Now we are talking about this finally block. Finally block can only be written with a try block. Except try block you cannot write a finally only. Fine. There may be no catch, but there may be a finally block. You may write, you may not write. What is the function of this finally block? The function of the finally block is the code that is written under this finally block. It must be executed whether the exception occurs or exception doesn't occurs. It doesn't matter. It doesn't matter whether exception occurs or not occurs. Your finally block, if you have written the finally block in your try catch program, rather in your exception handling program, your finally block must be executed. Then my next question or natural question comes, then what is the requirement of this finally block? Because finally block gets executed whether exception occurs or exception doesn't occur. In both the cases, finally block gets executed. Then why we use this finally block? What is the advantage of using this finally block? The advantage of using this finally block is, suppose you are going to write a file handling program. Fine. When you are writing a file handling program, there is a part which we must have to write, that is closing a file. This part, like closing a file, that instruction I will write under the finally block. Why? Because if exception occurs, then what we have seen, we seen that the rest of the statements, if it is not handled, the rest of the statements will not be executed. Fine. And if it is handled, it will be just jumped from try to catch block, and from catch block it will never return to the try block that I discussed in my last lecture. So if the closing part of this file closing part, if I write it under finally, that part definitely gets executed whether exception occur or doesn't occur. It will not be a matter. So that's why this type of code, like SQL connection code, file closing code. SQL connection code means your code have a database connection. If you have a database and your program have a database connection, you are retrieving data from some databases. So when you are closing, you must have to close the connection. So if the exception occurs, if you write the closing part under try block, and if the exception occurs, that line will not be executed, because when exception occurs, it just jumps to the catch block and will never return to the try block. So this type of code, like file closing code, database connection closing code, this type of code we must written inside finally block. That is the utility of finally block. Finally block, you cannot write finally block with it only without any try catch block. You must have to write a try at least. Fine. You must have to write a try block, and thereafter you have to write finally block. What it says if exception occurs, doesn't occur, no matter, finally block code that you have written under the finally block, it must be executed. So try to execute the code. What I am doing over here, I have just uh, done a division operation 25 by 5, and system.out.println data, that result is gets printed, and as because it is a non-zero value, 5 is a non-zero value, so no exception will occur. And the type of exception given is null pointer exception. I'm coming what is actually null pointer exception. When null pointer exception comes, that I explaining later on. So this catch block is taking a null pointer exception. Never, it will not throw an exception at all, because the 5 is a non-zero value. So division operation will be performed successfully. As because no exception occurs, so there is no question of execution of this catch block. Fine. Finally block gets executed, so result will consist finally block is always executed, and finally it will come out from try catch and finally block, and this shows the result rest of the code. This is the code outside of the try catch block. So let me execute the program and showing you the result. Look, I hope this much is clear. It is 25 by 5. Fine. So result is giving 5. Finally block is always executed. It is coming. And finally this line, that is the outside of try catch block, rest of the code. So this is the utility of the finally block. So important question, what is the utility of this finally block? Why we have write finally block inside a try catch program? This is the utility. Do you have any doubt? Hello?
No, sir.
Yes.
Clear? Is this clear?
Yes, sir.
Okay,
Yes, sir, clear.
fine. Moving to the next part. Look, just modified the previous program, last program rather. What I have done in the last program, 25 by 5. Fine. Now instead of 5, what I have given, I have put in a 0. Fine. So what it will throw? Definitely an exception. What type of exception? What type of exception it will throw?
Null type of exception.
No, no. It's already shown in the last lecture. Division by 0. Which type of exception it is?
Arithmetic exception.
It is arithmetic exception. Try to understand. The exception occurs in this line is 25 by 0. Division by 0 operation. The exception occurs here. It's a arithmetic exception. Arithmetic exception, division by 0, arithmetic exception. But in the catch block, I have written a null pointer exception. So as because I have declared a null pointer exception reference, that means what this code throws, this try block throws an object of arithmetic exception. So no catch block is there which will catch that thrown exception object. No. Nobody is there, no catch block is there which can accept this exception, rather this thrown exception. Fine. It is throwing an arithmetic exception type of, but the catch block that I declared, it's a null pointer exception, which is not matching with the thrown one and the declared one. That's why the exception thrown over here is not handled. Look, the first line, that's why I have written exception occurs and not handled. Though you have a catch block, but that catch block parameter is not similar type of what it is thrown. If instead of this, look, first try to execute this program, then I'm replacing this. Show the output. Output is finally block is always executed because exception occurs, not handled, program stops, but as we know, just know that finally block will always be executed if exception occurs, not occurs. So final output of the finally block is just get printed. Finally block is always executed. That is the SOPLN line. Fine. As because the exception occurs and not handled, so that's why program stops over there. So that's why it is written java.lang.arithmetic exception division by 0, and it is not handled over here. So exception occurs, not handled. Why not handled? Due to the different type declaration of this catch block. Instead of this null pointer exception, if I put it only exception, will it work? Definitely. Look, exception occurs, throws exception object. I have declared exception. Exception is the parent class of arithmetic exception. And the concept of inheritance says us that the reference of the parent class can point to a child class object. So arithmetic exception is the child class of the exception class. So reference of the exception class definitely can point to a child class object. That is arithmetic exception type. So now it can be handled by using this catch block, and it prints E. So the value of E is this java.lang.arithmetic exception division by 0. Fine. Then finally block gets executed. Finally block is always executed. Then the outer part of this try catch block, that is rest of the code. We are considering an example of class box which have this 3 member variable wh, D. Now what I'm doing, I'm just declaring a constructor box W equal to 5, H equal to 5, B equal to 5, and defining a method that is returning the volume of the box object. Then going to define my main method. Sorry. Then just printing the volume of this box object. So this much we have already knows in from the normal programming example. Semicolon missing, bracket missing. Yes.
The semicolon.
Line number 17.
Box OB1 new box.
Fine. So it is showing the volume 5 into 5 into 5 as because in constructor I have assigned the value of WHD all are 5. So 5 into 5 into 5, it's giving us 125. Fine. Next, what I am doing, 24. So now if I set the OB1 equal to null, and after assigning the null value to OB1, if I calculate the volume of that OB1, what will happen? Sorry, this will accept the null NULL. Look, exception in thread main, java.lang.null pointer exception. So an exception occurs. Why this exception occurs? What is this OB1? This OB1 is nothing but a reference of box class that I earlier discussed with you. Now when I am writing OB1 equal to null, that means earlier OB1 is pointing to an object of a box class. When I am setting OB1 equal to null, that means what? OB1 is pointing nothing. No object is pointing by OB1. And the very next line when I'm going to calculate the volume of that OB1 object, definitely, as because it is pointing no object, but I am going to calculate the value of rather volume of an object. So definitely an exception will occur. So this type of exception is called null pointer exception. This type of exception is called null pointer exception. And when I am executing the program, it is coming in the output screen also that this type of exception is called. What type of exception occurs? It's a java.lang.null pointer exception. And that's why the program, as because it is not handled, that's why the program stops at that point, as because it is not handled. If you try to handle it, then you have to write this code inside under try catch block, and inside catch block, just like example 24 or rather 25, you have to write the type of the catch block, the type of the reference in the catch block, you have to declare it as null pointer exception if you try to handle it. So what is null pointer exception? I hope this much is clear to you. This example I already discussed with you, where exception occurs and not handled. Now this one, exception occurs and handled, and for each try block there can be 0 or more catch blocks, but only one finally block. Points to be noted. For a single try block, you can have 0 or more catch blocks. Yes, that already discussed, already shown in different example. But point to be noted in this example is only one finally block. Your try catch block cannot have more than one finally block. Suppose one more thing I need to show with this example. Look, I have omitted the catch block from this example. Fine. Try block is there. I have omitted the catch block from this example. And when I will compile this program, it is not showing any error. Fine. But earlier I mentioned your program may have a finally block, may not have a finally block. So if I omit this finally block, only I have try block. I don't have any catch block. Fine. If you compile this program, look, it is showing an error. So a try block can be 0 catch block, can have 0 catch block if there is a finally block. Otherwise a try block must have at least one catch block. This point should be noted. A try block can have 0 catch block if you have a finally block. But if you don't have any finally block, because finally block is optional, that I already discussed. So if you don't have any finally block, so you must have to write at least one catch block. Otherwise, it will give compilation error. What is finally block? We all know the code segment of the finally block is it must be executed. Exception occurs, doesn't occur. In all the cases, the content of the finally block must be executed. So here, what I have written? I've written finally, I have only finally block. I don't have any catch block for this try. This an exception will be occurred over here. What type of exception? It's an arithmetic exception, division by 0. Fine. So as because this exception occurs, but we don't have any catch block because I have commented the catch block. And this time, if I compile the program, compilation is successful, process completed. Fine. So try block without any catch, but have a finally block. Now, in the second phase, what I have done, I have also commented the finally block. So only a try block is there. There is no corresponding catch block and no corresponding finally block. So in this situation, if you compile, you will get error. You will get compilation error. So my conclusion is a try block can have 0 catch block if you have a finally block. If you don't have any finally block, then your try block must follow at least one catch block. Otherwise, it will give you a compilation error. Your program may have more than one. Your program may have more than one catch block, but if you try to include the finally block, the number of finally block should be maximum 1. You cannot include more than one finally block for a single try catch block. That is the point highlighted in this example. Moving to the next example, that is throw keyword. So far we have learned we learned try, we learned catch, we learned finally. Now we are going to learn another keyword, that is throw, which is used in the exception handling case. What is the purpose of using this keyword? This keyword is used to explicitly throw an exception. Better to say, explicitly throw an exception object. Because so far, the example that we discussed, in all examples, exceptions objects thrown implicitly when exception occurs. Just like division by 0 exception. When we are going to division by 0 operation, then that type of exception occurs and your program throws that type of exception. Another type of exception we have discussed, that is array index out of bound exception. When it occurs, when I am trying to access an element which is not in the declared array size, that time array index out of bound exception occurs. Today I have shown you another type of exception, that is null pointer exception. We are trying to access an object which is existing null. Currently it is null. Currently the reference is pointing null. If I try to access the object again of this null reference, we are getting that exception. And when the exception occurs, that will be thrown. That implicitly thrown. Now, in this example, we are throwing an exception explicitly. That is the difference between this program and the previous programs. We are going to throw our exceptions explicitly. Means we are declaring that we are throwing an exception. We are declared that we are throwing an exception. Look, have written a validate function which is static. We all know what is the meaning of static keyword if it is used with a function. If it is used with a function, the meaning of the static keyword is there is no requirement of an object to call the method. Static method can execute with its own. No object is required to execute. No object is required to execute that particular method. So I have declared a method named validate, which is static, which is taking one parameter. The name of the parameter is age, and which is integer. What I am doing over here? Is if age is less than 18, that is the parameter value. If the age is less than 18, I am explicitly throwing an arithmetic exception object. New arithmetic exception. What is the meaning of this? We know new class name. New class name is basically created an object. So here new arithmetic exception. So it is creating an object of which class? Arithmetic exception. Passing a parameter not valid. I will show you what is the utility of this pass parameter not valid. Just keep it in mind. Not valid. And what is the keyword you have to write? That is throw. Throw is the keyword which is used to explicitly throw any type of exception. Here there is no question of arithmetic exception occurs because no division by zero operation or no other type of operation occurs so that our arithmetic exception can occur. But we explicitly throw an arithmetic type of exception object from this point of this program. Throw new arithmetic exception, and we have passed a parameter that is not valid. Fine. Now this is the else part. Exception not occurs. Fine. As because it is throwing an exception, as we know this function validate 13 I have passed, so definitely it will throw an exception. So I have to write this code inside try block. Inside try block I have to write this code, otherwise the program will stop at that particular point where exception occurs. So if you not write it inside try catch block, the program will just stop over there. As because it is written inside try block, so when exception occurs, because you explicitly declared this part, this function will throw an arithmetic exception object. So that's why this validate function will, when the value is less than 18, so it will throw an arithmetic exception, and naturally it comes to the catch block. After catch block, it printed, the value of gets printed, and this is the outside of the try catch block code. That is the rest of the code. That is the outside of try catch block code. Now I am trying to execute my program. Look, I have passed value 18. So as because I have passed the value 18 and I am going to print the value of look, java.lang.arithmetic exception occurs, and at the same time not valid gets printed. Earlier it was division by 0. It shows division by 0. Now, as because I have passed the string not valid as a parameter of this object, so instead of division by 0, so it is nothing but an overloaded constructor. Arithmetic exception is an overloaded constructor. So I can pass my own string in this case, similar to this case, that is not valid. So instead of division by 0, in my previous example it gets printed division by 0. Now it gets printed not valid. because I have first not valid to the arithmetic exception constructor. Finally, that is the outer part of the try catch block, that is rest of the code gets printed. Fine. Now I am putting one more value over here, that is 20, which is greater than 18, so that no exception will be occurred. As because no exception occurs, look, welcome to vote, that it enters into the else part. Welcome to vote. No question of this catch block, and finally rest of the code gets printed. So using throw keyword, what we can do, we can explicitly throw an object of any exception class. By default, unchecked exception are forwarded in calling chain. What is unchecked exception? Unchecked exception is the exception which occurs at the runtime. At the compilation time, it will not show any error, right? So what it says by default unchecked exception are forwarded in calling chain. Try to understand. Class test, which have three methods. One is m, void m. Another one is void n. Another one is void p. Void m, void n, void p. Fine. This is the method defined under class test 28. And inside main method, I have created an object of class 28, that is obj, and on obj I am calling the method p. So that means this part gets executed. Fine. Inside p method, n gets called. Fine. So this definition gets called. Try to understand. N gets called. When n called, the definition of n says it will call the function m. Again, it is calling the function m. Look. Fine. And the definition of function m says there is a division by 0 exception occurs, rather arithmetic exception occurs. But we haven't handled this arithmetic exception separately for method m. Why? The reason is this. Unchecked exception, I'm talking about unchecked exception. Which are unchecked exception, we all know. Unchecked exception are forwarded in calling chain. That means when this exception occurs in m, it will be forwarded to n, because m is being called from function n, and when it is forwarded to n, at the same point of time, n forward the same thing to p, as because the function n gets called from function p, and inside p we have handled this thing. That's why we haven't written this code m, void m, inside try block, or rather we don't have any catch block for this exception. Still it gets handled. So what is the written inside handle exception E? That is written exception SOPLN exception handled. And finally the normal flow. So let me execute the program. Look, exception handled and normal flow gets printed. So why exception handle gets printed? As because exception is throwing from the function m. As because m is called by function n, definitely it will be forwarded to function n. As because it is not handled over here. In n, in function n also, there is no handled code, there is no try catch block. So that's why the exception that is forwarded by m, it will be again forwarded to p, as because function n gets called from p. And inside p, there is a try catch block to handle. So through this catch block, that exception will be handled, which is occurred in function m. And that's why you are getting the output exception handled, and finally this normal flow, which is outer part of the try catch block. So I hope this much is clear to you. Checked exception. In the just previous example, what we discussed? We discussed by default unchecked exception are forwarded in calling chain. Now I am going to discuss checked exception are not forwarded in calling chain. We know what is checked exception. Checked exception is a type of exception, just like IO exception, file not found exception. This type of exception you must have to declare, or rather it must have to handle, that I earlier mentioned. And now what we are trying to say, we are trying to say that these checked exceptions are not forwarded in calling chain like unchecked exception. Look, void m is the function. We are explicitly throwing an exception of type which? IO exception. IO exception is a type of checked exception. And just like similar previous program, from function n I am calling m, from function p I am calling function n, and it is handled only in the definition of function p where n is gets called. And at the similar of the previous one, what we have done, we just created an object of this test29, that is my class, and I have called the method p on that object obj. Fine. So as I am calling the function, I am calling the function p on the obj object. So what it will do, it will definitely call, it will try to execute this method p, n gets called. When n gets executed, m gets called. When m gets executed, it explicitly throw an IO exception object. And as because this exception is not handled over there, and as because it will not be propagated to the propagated chain, rather calling chain, so the program will be stopped over there. Fine. And look, the error comes. What type of error? The error is, it's an unreported exception IO. One error is coming because you haven't handled, and as because it is a checked exception, that's why at the compilation time you are getting this error. That is the difference between checked and unchecked exception. As because you are not handled, or rather you have not declared, I will show you how to declare this function in case of how to declare exception when this type of exception, rather checked exception occurs. The function needs to declare yes, just like this, public static void main throws IO exception. Why we have written this throws IO exception? Because in the method main, on the function main, we have used a buffer reader class, and which may throw, and there are input stream reader class, buffer reader class, they may throw an object, or rather an object of IO exception type. So either you have to handle it, or you have to declare the method that throws IO exception. But here function M is not declared that it throws IO exception. So that's why this error is also coming. And as because it is not handled at the time of execution, it just gets stopped. Fine. So unlike previous one, the conclusion is unlike previous one, unlike unchecked exception, checked exception are not forwarded in calling chain. So it will not forward it from function M to N, from function N to P. So that's why the program is getting stopped over there inside function M. Okay. Moving to the next example. What it says throws clause which describes that checked exception can be propagated by throws keyword. That is the declaration I just mentioned in my last example. Look what it's trying to say. It tries to say throws clause, throws, not throw. So far we learned keyword throw. Now we are going to learn throws. What is the purpose of this keyword throws? So we learned throw. What is the meaning of throw? The meaning of throw is it is used to explicitly throw an object of different exception classes. Again, I am repeating, it is throw keyword is used to throw, explicitly throw, better to say, explicitly throw an object of different exception classes. But what this throws keyword does, the throws keyword, using this throws keyword, we can propagate the checked exception. We can propagate the checked exception. Look, now what we have modified the last program, we have just included this part, throws IO exception for function M and throws IO exception for function N. So what is the consequence of this writing? Rather, why we have used it? The reason behind this is when I am calling the method P, it try to execute this part as per method definition. As per method definition, function N is being called, and as because function N declares or rather propagates, it is throwing a IO exception function. So that means it must be written inside try catch block. From function N, function M gets called, and function M also declaring the same thing. It is declaring that function M throws IO exception. So both the function M and N, both the function M and N are throwing what? Throwing IO exception. So actually exception occurs in this method. Exception occurs in the method M, because in the method M I explicitly throw an IO exception object. Earlier, the program gets stopped in this point because it will not automatically propagate it to the caller. When exception occurs, the exception will not automatically propagate it to the caller. As per our discussion, we have discussed this thing. Now, we explicitly propagating that exception to the caller. How? This is the way. Writing throws IO exception. That means it explicitly it is saying that it will propagate the IO exception occurs in this method to the caller. So m is throwing that exception to the caller. Who is the caller for the function m? It is n. N is not handled yet. So what n does? Again, n declares that I am also throwing IO exception. Which IO exception? That I am getting from m. Fine. So n throws IO exception again. And when to whom? N throws IO exception to whom? Definitely to the caller of n. Who is the caller of n? It is p. And when the exception throws, that means n is throwing that exception, IO exception, this catch block will handle it by writing system.out.println, by whatever the code that we are writing inside this catch block will handle that. So the difference between checked and unchecked exception is this one. This one point may be noted. That is, in case of unchecked exception, it is automatically propagated to the caller. But in case of checked exception, it will not automatically propagate it. The solution is each and every case you have to explicitly use that throws keyword. You have to explicitly use that throws keyword to propagate it to the caller. And if you execute the program, now this will execute fine. That will never be stopped because we have already propagated the exception. Look, the answer is exception handled. Exception occurs, rather you explicitly throw that exception, not occurs. You have explicitly throw an exception, that is type of IO exception, and this is try block. Inside this try block this occurs. I explained how it occurs, and finally this catch block will handle it. The output of this catch block is exception handled, and finally you are getting this line, normal flow. That is the outer part of the try catch block, exception handling part.